Dear students, welcome to Mathematics Online classes. In this class, we will study the concept of components of a vector. Say, suppose there is one vector, it will be having two types of components. One is it's a scalar components, another one is a vector components. So let us study what are those vector components and scalar components of a vector. See, I will consider a three-dimensional plane here with three axes. This is x-axis, this one is y-axis, and then z-axis. Next, already we know unit vectors along the x-axis, y-axis, and z-axis. Let us take unit vector along the x-axis. Unit vectors along x-axis. What is that? We have studied in the previous class this as a I cap. In the same way, what is the unit vector along the y-axis? It is j cap. Then unit vector along the z-axis is k cap. Fine. Now here I want to do, I want to represent a point P of x comma y comma z. Means I am considering position vector of the point P with the coordinates x comma y comma z. Okay. Then this will be origin. Point P coordinates are x comma y comma z. To represent it, what we do? We will move x units along the x axis. We move x units along the x axis. Yes, somewhere here is the point. Let us name this point as a. Then what will be the vector OA here? Vector OA will be x into I cap. How vector OA is x into I cap? We are representing the point x comma y comma z. X is the x coordinate value here. Means to represent it, we have to move how many units? X units along the x axis. Which direction? I cap direction. So it is x into I cap. Next, to represent the point P of x comma y comma z, y coordinate is y here. Now what we need to do? We need to move y units along the y axis. Y units along the y axis. Here it is. But we are representing the point, we should not take it as on the plane. Here it is actually x axis, we have moved x units. Now we are here. Then to move along the y axis, what we do? We will move here. Means we are moving on xy plane. This is xy plane actually. This is xy plane. This is zx plane, and this one is a yz plane. Three planes are there here. Along the x axis, we have moved x units. Now this is x into I cap. Y. What we do? We will move y units along the y axis. Y units along the y axis. Now somewhere here is the point B. See, instead of moving on the moving on the xy plane, suppose you move on the y axis itself, where you will be? You will be somewhere here. Let us name this point as C. And what will be this OC? OC will be y into j cap, because y units along the y axis. In the same way, this will be parallel, See, here is x axis. Now we are moving y units along the y axis. This line will be parallel to the y axis. So what happens to the AB? AB is also y into j cap only. It is parallel. It is equal. Equal means it will be having equal direction, same direction, and same magnitude. Okay. Next, what to do? Next is representing the z coordinate. How will you represent a z coordinate? We will move z units along the z axis. See, we are on the x axis, x comma 0 comma 0. Then we have moved on the xy plane. Now here is the point x comma y comma 0. That means this point is x comma y comma 0. Then x comma y comma z is there. What do we do from here? From here we will move z units parallel to the z axis. So it goes like this. Now we should not think like it is on the plane, it is in space actually, it is in space. Okay, it is in space. Say x units along the x axis, then y units along the y axis, that means we are on the xy plane. Then what we do, from here onwards we move z units along the z axis, keeping the z axis parallel, means we are in the first octant now, we are in the first octant, that means we are in space. Yes, we are here. This point is, let me take this point as D. Okay, otherwise I will take this point as P. What is this P coordinates? P coordinates are x comma y comma z. This is how we represent a point in a three-dimensional plane. Same way as we do in case of a two-dimensional plane. In two-dimensional plane, only two coordinates will be there. Here, three coordinates. That's all. Then let me complete this figure. Here, okay, one more thing I have to say. Next, you see, instead of moving in the space, if we move z axis, z units along the z axis, somewhere here will be the point. Let me take this point as D. And what will be this OD? OD, it is along the z axis, having the z units of length. So this can be written as z into k cap. This OD is there, OD is parallel to BP. OD is parallel to BP. So you can write the directions also, no problem. You can write the directions like this. Like, okay. OD is parallel to BP. That means this BP is also what? BP is also Z into K cap. BP is also Z into K cap. Okay, now parallel to this BP, I will write here. I am completing this. Okay, this is about a point P. Point P is in the space. Now what I want, P is the point, with the coordinates x comma y comma z. I want the position vector of point P. Let position vector of point P is, let position vector of point P is vector OP is equal to vector R. OP is the position vector. I told you already about the position vector. Means position vector in the sense it will be starting from the origin and ending at the given point. OP is position vector of the point P. Now from origin, if you join, this will be OP vector and it will be taken as a R bar. Vector R bar. I have taken vector OP as a vector R bar. Now vector R bar we will write in terms of a component form. How will you write the component form? See, I told you in the previous class also, this is x axis, this is x axis, and from here onwards we move along the y axis. Here it is. This will be 90 degree, right? This will be 90 degree. Means here is 90 degree. As here is 90 degree, let us join this O and B. Let us join this O and B. What will be the vector OB? What will be the vector OB? Vector OB I am writing here. See, I can use the triangle of vector addition here. Vector OA is the first vector and vector AB is the second vector. Vector OA terminal points is getting coincide with the vector AB, that is second. Initial point is getting coincide with terminal point of first vector OA. That means vector OB is equal to what? I can write here like vector OB is equal to vector vector OA plus vector AB. How is this? This is according to the triangle law of vector addition. Then I have vector OB is equal to very simple. vector OA is x into I cap and vector AB is y into j cap. This is y into j cap. We got vector OB. Now you observe the triangle you observe the triangle OBP. OBP you observe. OB is the first vector, BP is the second vector. According to the triangle of vector addition, I can add these two, OB and BP, that gives us vector R. Very simple. Now from triangle of vector addition, I can write vector OP is equal to this vector. This is by the adding vector OB first vector and vector BP, that is second vector. Vector OP is equal to vector OB plus vector BP. Yes. Now vector OP I have taken as a vector R. Vector R is equal to, I got already vector OB. Vector OB is x into I cap plus y into j cap plus, then what about the BP? BP is parallel to OD, that is z into k cap. You see, this is z into k cap. What is this? This is the position vector of point P, that is taken as a vector R, that is equal to x into I cap plus y into j cap plus z into k cap. This form is known as a component form of the vector. What are the components there? Components are two components. What are those? Scalar components and vector components. What are the scalar components in this vector? Scalar components are x, y and z. Scalar components are x, y, z. And then what about the vector components? Vector components of these vectors, this vector is x into I cap, this is first component, y into j cap, another one component, z into k cap is a third component of the vector. See, components of a vector, if they ask you, you should write it like, what are the coefficients of I cap, j cap and k cap are there, those are the scalar components, that's all. In this, vector R is equal to xi plus yj plus zk. Scalar components are x, y, z. Vector components are x into I cap, y into j cap, and then z into k cap. This is about components of a vector. Now, this component form of vector, I will write it in general. And I will tell you something about direction ratios and direction cosines once again in case of component form how it will be. You see here general way of representation how it will be. General representation of a component form of a vector. It will be taken as vector R is equal to AI plus BJ plus CK. What is this ABC? ABC are coordinates of a point. As here x, y, z are there, in the same way in general we used to take it as AI plus BJ plus CK. What are these ABC are called? ABC are called as direction ratios. What are the direction ratios of the line? Direction ratios are A, B, C. In the same way, we are representing the point P of x, y, z here. So that will be vector R is equal to xi plus yj plus zk. What are the direction ratios? Direction ratios are x, y, z. Scalar components are nothing but direction ratios. Now what we do for this? We will divide by magnitude of the vector. Magnitude of the vector, if you divide, what is the magnitude here? Magnitude vector R is equal to, magnitude of vector R is equal to, this is square root of a square plus b square plus c square. That is nothing but length. How will you find out this one? See, p of x comma y comma z is a point from the origin it is drawn. So first point is 0 comma 0 comma 0. Second point is x comma y comma z. Its length will be using the distance formula in 3-dimensional plane, that is square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay, I can write its magnitude as magnitude of vector r is equal to square root of x square plus y square plus z square. In the same way here, this vector is ai plus bj plus ck, ai plus bj plus ck. Then magnitude will be vector r is equal to square root of a square plus b square plus c square. That's all. Then what are the direction cosines here? What are the direction cosines? Direction cosines are if we divide by its magnitude, those will be direction cosines. First direction ratio is a divided by magnitude of vector r, and then b by magnitude of vector r, then c by magnitude of vector r. This is nothing but what? This is nothing but direction cosines. In this one also we can explain this using the triangle, using the triangles here, cos alpha, cos beta and cos gamma. I told it in the first video. In the same way here, these are the direction cosines, you know. I can write cos alpha is equal to L is equal to a by magnitude of vector r, or this is also equal to a by square root of a square plus b square plus c square. Then in the same way, next cos beta is equal to, what is alpha, beta, gamma? Alpha is the angle made by the vector with the x axis. For this, cos alpha is equal to, how is this? We can watch the first video. Cos beta is equal to, we used to represent it as m. Cos beta is equal to b divided by magnitude of vector r. This is b by square root of a square plus b square plus c square. Next, what about the cos gamma? Cos gamma is equal to Lmn it is. This is c by magnitude of vector r. This is equal to c by square root of a square plus b square plus c square. Okay. Now, one more thing we can observe here. If you divide by magnitude of this and if you write this as vector, means if you write vector r is equal to, we used to write it as r cap. Vector r is equal, let me explain this by taking vector r is equal to, if you are divided by magnitude of all this, a by vector r I cap plus b by vector r j cap plus c by vector r k cap. What is this? We are dividing by the magnitude of, the given vector, you know. This will be what? This will be unit vector in the direction of vector r. It will be unit vector. That means here scalar components are what? Scalar components are nothing but direction cosines. Yes, scalar components are direction cosines. A by magnitude of vector r is nothing but you can write it as Lmn or cos alpha, cos beta, cos gamma also. Let me write it as Li, and this will be Mj, this will be Nk and N, and then vector r is equal to, vector r cap equal to, it can be written as cos alpha I cap, then it is cos beta j cap, then it is cos gamma k cap. What is this? This is unit vector in the direction of the vector r. We are dividing by the magnitude, that gives us, or else we can write here directly. I wrote vector r equal to, just to make sure you understand this, r cap is equal to vector r by magnitude of vector r only it is. Yes, we are doing this one. We have to be careful here. If the scalar components are direction ratios, if the scalar components are direction ratios, then that will be a vector. then that will be a vector. Simply we used to say it as vector. Vector will be having some magnitude, 2 units or 3 units or whatever it is. If the scalar components are direction cosines, if the scalar components are direction cosines, then that will be unit vector. Then that will be unit vector. You see, you hear the scalar components are what? Scalar components are L, M, N. Here cos alpha, cos beta, cos gamma. L is nothing but what? A by magnitude of vector R. Yes, we have to be careful. Scalar components and vector components. We have studied all these concepts under the heading of components of a vector. Now, suppose there are two vectors in the component form. How to add, how to subtract, how to multiply a scalar to the vector, all those we are going to study. And then also, if there are two vectors in general, how they are equal, means what are the conditions for equality of two vectors. Let us see all those. See, let A and B are two vectors. Let vector A is equal to, it's a scalar components, I will take it as A1, B1, C1, and a second scalar components I will take it as A2, B2, C2. Let vector A is equal to A1I plus B1J plus C1K, and vector B is equal to A2I plus B2J plus C2K are two given vectors, Then under that, first one, addition of these two vectors, addition of vector A and vector B. How will you add these two? See, vector A plus vector B is equal to, vector A is A1I B1J plus C1K plus of, next second vector is A2I plus B2J plus C2K. It is very simple. What you do, you add the corresponding components here. Corresponding components you add. What are the corresponding components? Here I component is A1 and here I component is A2I. So these two we need to add. This is A1 plus A2 into I cap plus next J components you observe. It is B1 plus B2 into J cap. Next Z components, that is C1 plus C2 into K cap. What is this? This is vector A plus vector B is equal to. Suppose two vectors are given in component form, then how to add it? This is how we need to add those two vectors. In the same way, subtraction of vectors. Subtraction of vectors. Subtraction of vector B from vector A I am doing here. That means I am taking vector A minus vector B. In the same way, we can try with vector B minus vector A also. What is vector A? Vector A is A1I B1J plus C1K. We are subtracting the vector B, that is A2I cap plus B2J cap plus C2K cap. This minus will get multiplied to all the terms. I can write here, this is A1 into I cap plus B1 into J cap plus C1 into K cap minus A2 into I cap. I like that we can write. In the case of subtraction of two vectors in the component form, how we should subtract, same way we need to subtract corresponding components, that's all. Corresponding components, here A1 is there, here A2 is there. You write it as A1 minus A2 into I cap plus of, next J components subtraction, B1 minus B2 into J cap plus, next last component C1 minus C2 into K cap. What is this? This is vector A minus vector B is equal to. If you write vector B minus vector A, what happens? That will be A2 minus A1 into I cap plus B2 minus B1 into J cap plus C2 minus C1 into K cap. Okay. This is about a subtraction. Now, third one. When two vectors are equal in this case, equality of two vectors A and B. See, here it is given vector A is equal to A1i plus B1j plus C1k. Vector B is A2i plus B2j plus C2k. Here they are saying that vector A is equal to vector B. In case of component form, these two vectors are equal only when their corresponding components are equal. Their corresponding components are equal. Only then, means if the all corresponding components are equal, then only we will be having the magnitude and direction of those two vectors equal. Already we know the definition of equality of two vectors. Two vectors are equal only when their magnitudes are equal and their directions are equal. Here, in case of component form, that condition has to be satisfied. That condition has to be satisfied. To satisfy that component, to satisfy that condition, here in the component form, vectors should have same components. Then only they are equal. Otherwise, no. Same components in the sense what? Here I component is A1, here I component is A2. Means we should have A1 is equal to A2. Then J components has to be same again. That means B1 should be equal to B2. Next last one is C1 should be equal to C2. These three conditions should satisfy. Then only the given two vectors are equal. Otherwise, no. Then one more thing we will study here, multiplication of a scalar to a vector. Multiplication of fourth concept, it is multiplication of a vector, multiplication of a scalar to a vector. That means let us take the scalar is equal to lambda and a vector A is equal to, let me write vector R is equal to AI plus Bj plus Ck. Then what will be the lambda into vector R? Means what? For the vector R, we are multiplying one scalar value. Scalar value can be 2, 3, 4, like minus whatever it is. Lambda into vector R is nothing but lambda into AI cap, Bj cap, Ck cap. This lambda is there, no? Lambda will get multiplied to all the terms. This can be written as lambda A into I cap plus lambda B into J cap plus lambda C into K cap. In the same way, suppose there is common from all three components. Can we take it out? Yes, we can take it out. See how we have multiplied this. Fine. And then fifth property I want to say here, multiplication of vectors and scalars. See, suppose there are two vectors, let vector A and vector B, and also L and M are given. What are L and M? L and M are scalar values, and vector A and vector B are two given vectors. See, suppose I have L plus M into vector A, L plus M into vector A, then what I can write? I can write here L into vector A plus M into vector A, like that I can write. This is valid. This is known as a distributive law. In the same way, suppose I have Lm into vector A. Lm into vector A is there. I can take here like L into vector A, which is multiplied with M, and also this is equal to M into vector A, this is multiplied with L. Like this you can take, no problem. Next, third one, suppose I have L into vector A plus vector B is there. Now L, can we multiply with both? Yes, we can multiply with both. This can be taken as L into A cap plus L into vector B. Sorry, it is vector A plus L into vector B. Like this we can take. This is about multiplication of scalars and vectors. Scalars means definite value. Vectors means it will be having direction and magnitude, both. This is about components of a vector. In the next class we will study another one concept. Thank you.